That right there, that's compressed air doing the mechanical work. No motor, no gears, no electricity driving that movement, just air pressure. And that single principle powers the brakes on your bus, the doors on the tube, and the robots building the car, and many, many things. Welcome to the Engineering Geezer. I'm Mel. And in this video, we're starting from absolute scratch with pneumatics. By the end of this, you know what it is, how it works, and we would have built a circuit together using the TP101 board from Festo. Let's get to it. So, pneumatics, what actually is it? The word comes from the Greeks, pneuma, meaning breath or air. That's basically it. Pneumatics is the use of compressed air to transmit and control force and motion. Now, why air? Why not just use hydraulics, which does the same job, but with oil? Good question, people say, but it's well worth knowing the answer. Air is everywhere. You do not need to manage a fluid reservoir, okay, a oil tank. If there's a leak, air just escapes. No mess, no contamination risk, or cleanups. For fast, light, clean movement, air is perfect. Hydraulics wins when you need enormous force. Think of steel pressing, car lifting, digging a hole with a digger, okay? But in factory automation, food production, packaging lines, pneumatics is king. The principle is dead simple. Compress air with a compressor, store it in a reservoir, control where it's going, control where it goes using valves, then use it to drive actuators, things that create movement. Pressure, flow, direction, that's the whole system. Right, let's talk about this kit. This is the Festo TP101. If you're on a BTEC course, there's a very good chance your college has one of these. And this is the kit the whole series is built around. Let me walk you through each component. I'll tell you what it is, what it does, and what the ISO symbol looks like. First, your air source. In industry, this is a large compressor. On the TP101, we're connecting ours to the bench compressor, as you see there on the floor there. This is where your compressed air comes from. Simple. Next, this unit is called an FLR, filter lubricator regulator. 3 jobs in one. The filter cleans the air, strips out the moisture and particulates that could destroy the valves. The regulator sets your working pressure. We typically run at 4 to 6 bar for this kit. And the lubricator adds a fine oil mist to keep moving parts inside your valves and cylinders healthy. If your circuit ever behaves erratically, sticking, slow moving, inconsistent response, 9 times out of 10, it's this pressure or filtration issue. The FLR is the first thing you'll check. This is the valve, specifically a 5-2. 5 ports, 2 positions. This is the brand new circuit. It decides where the air goes. In position A, air drives the cylinder out, and in position B, air drives the cylinder back. The symbol looks complicated at first glance. Don't panic, we'll break it down properly in video 2. For now, just understand it controls direction. And here's your actuator. Double acting cylinder. Double acting means air drives it both ways. Extend and retract. 2 ports, 1 on each end. This is what does the work. In industry, you might be clamping a component, pushing the product down the line, operating a press. Finally, your inputs. These are push buttons that send a pilot signal to a valve. Press it, the valve switches, cylinder moves. That's your basic manual circuit. We'll add solenoids and sensors later on in the series. This is the next day. Before we go any further, quick word on symbols, because this is where a lot of students come unstuck. Come close and have a look at these old boys over here. Every component in pneumatics has a standard ISO symbol. Doesn't matter what brand of kit it is, what country you're in, the symbols are universal. Learn them once, you can then read any circuit diagram anywhere. The mistake students make is trying to memorize symbols in isolation. Don't do that. Learn the component first, what it physically does. Then the symbol makes sense because it represents the function. Look at the cylinder symbol. 2 horizontal lines with a piston rod That's literally a cross section of the cylinder. The valve symbol shows flow paths switching between two boxes. It's all logical once you see it that way. In this series, every time we introduce a component, we do exactly this. Physical first, symbol second, that's how it sticks. All right, let's build something. We're going for the simplest possible circuit. Press a button, cylinder extends, release it, cylinder retracts. Connect the compressor line into the filter regulator that we have here. We do not have a lubricator on this system here. Now, that there is going to go through this switch here, and that is going to go into the manifold here. This is where I'm going to feed my pressure lines from to feed all the other components in the circuit that you see here. So we're still coming directly from the FLR. What we're going to do is come directly from the manifold, and we are going to go from any one of these ports, okay, into there. Now, if you do leave the air on, switch it off. Make sure it's safe so none of these will wang around on you. And this one's going to go to port 1 on our 5.2 valve, which is this one here. That's the centre one there. The two side ones you see there are exhaust, and then we have port 4 and 2 up here. Ignore this one for now. So from there, step 3, port 4 of the 5.2 valve goes into the end cap side of your cylinder. That will extend the cylinder, and port 2 will go into the rod end of your cylinder, which will then help that retract. That's the bit that retracts it. So extend and retract. Perfect. Ports 3 and 5 that you see down here are just exhaust ports. You have these little copper brassy colour things. They are silencers, so you don't end up with a massive hiss when it comes out. And finally, the push button. Now, this is coming straight from the manifold, and that is going to port 1. So that's a feeding one. You'll get the same thing. Port 1 is always the sort of feed for most of these valves that you see here. Now, when I do press this, what it has is going to open the valve and let air come out of here. So that's the bit I want to do something. Port 2 is actually going to go from the push button, port 2, and into port 14, which is the pilot side of the valve, which you see here. Just make sure none of these are loose. What you don't want to do is have one of these fly off on you when you power it up. As long as you've got the safety glasses on, you should be okay. Power's on. Everything's charged. Right, the moment of truth. There we go. Press, extends, release, retracts. That is a working pneumatic circuit. Nothing complicated, nothing hidden. Open, close. Extend, retract, all from this. So where does this series go from here? Video 2, we'll go deep on the 5.2 valve, how it actually works, what will 5 ports do, and how to read any valve symbol with confidence. Video 3, actuators, single acting and double acting, how to calculate forces and stroke length, and what to watch for in your BTEC project work. Video 4, we'll add logic and valves and all valves, building circuits that respond to multiple input conditions. Then we get into sequence circuits, which is where it all comes together for your assignments. The whole series is designed to take you from zero, which is where we start today, to generally competent with pneumatic circuit design. Whether that's for your BTEC unit and your project, or just this stuff is generally interesting, which it is, frankly. All right, my boys and girls, you now know what pneumatics is and why we use it. You know your TP101 components, you know how to read the basic symbols, and you've seen a working circuit built from scratch. If that was useful, smash the like button. It generally helps more people find the series, and subscribe so you don't miss video 2. That's coming very soon. Drop any questions in the comments. I read every single one, and I do the best to get back to you. Now, if this series is helping you out, there's a link in the description where you can buy me a coffee. Generally appreciate it. It keeps my kit fund going. Ciao for now. See you all in the next one.